Hello, I'm Jim Haxa, and have you ever wondered what's going on inside your computer? It seems like magic, doesn't it? You click a mouse, type on a keyboard, and suddenly a whole world of games, videos, and information appears on your screen. But it's not magic. It's science. Computers are incredible machines that help us do so many things in our daily lives. They help us learn new things for school, talk to friends and family who live far away, play fun games, and even watch our favorite cartoons. These electronic helpers have become a huge part of our world, and understanding them is a fantastic adventure. Think about all the places you see computers. They are not just on our desks as big towers or thin laptops. Your parents' phones are tiny computers. The checkout machine at the grocery store is a computer. Even some refrigerators and cars have computers inside them to help them work better. They are everywhere, making difficult tasks much easier for us. They can calculate really big numbers in a flash, store millions of books in a tiny space, and connect us to the internet, which is like a giant library for the whole world. Isn't that amazing? So, why are computers so important today on July 22nd, 2025? It's because they are tools that expand our own abilities. A computer can remember more information than any person ever could, and it can solve problems much faster. This helps scientists make new discoveries, doctors find new ways to keep us healthy, and artists create beautiful pictures and music. By using these powerful tools, we can achieve things that were once considered impossible. Learning what makes them tick is the first step to becoming a creator yourself. Let's get ready to peek inside the case and discover the secrets of these fantastic machines. We are going on a journey to explore the main parts that make up a computer. It's like looking at the organs of a body. Each part has a very special job to do. When all these parts work together, they create the wonderful experience we know as computing. You don't need to be a super genius to understand it. Let's break it down and see the science that powers our digital world. First up, let's talk about the computer's brain. This part is called the Central Processing Unit, or CPU for short. The CPU is a small chip, but it does one of the most important jobs in the entire computer. It's the thinker. Every time you click on something, type a letter or start a game, the CPU gets to work. It reads the instructions and performs all the calculations needed to make things happen. Think of it like a chef in a kitchen. You give the chef a recipe, your command, and the chef quickly follows all the steps to cook a delicious meal, what you see on the screen. A fast CPU is like a very quick-thinking chef. It can handle many instructions at once without getting confused or slowing down. When you play a complex video game with lots of action, the CPU is working extra hard to process everything that's happening. It tells the characters where to move, what to do, and how to react. A slower CPU might struggle to keep up, making the game choppy or laggy. That's why the speed of the CPU is so important for making a computer feel fast and responsive to your commands. It's the powerful engine that drives everything forward. Next, we have the computer's short-term memory, which is called RAM, or Random Access Memory. RAM is where the computer keeps the information it is using right now. Imagine you are doing your homework at a desk. You take out your math book, a pencil, and a notebook. All these items are on your desk so you can get to them quickly. RAM is like your desk. It holds all the applications and files you have open, like your web browser, your game, and your music player, so the CPU can reach them instantly. The more RAM you have, the bigger your desk is. If you have a small desk, you can only work on one or two things at a time. If you try to put too many books on it, things might fall off or get messy and slow you down. Similarly, if a computer doesn't have enough RAM, it can become very slow when you try to open many programs at once. It has to keep swapping information between the fast RAM and the slower main storage, so having plenty of RAM helps your computer multitask smoothly without any hiccups. Now, how do all these different parts talk to each other? They're all connected to one giant circuit board called the motherboard. The motherboard is like the computer's skeleton and nervous system all rolled into one. It's a big flat board with lots of tiny lines called circuits, and special slots and connectors. The CPU, RAM, and all other components plug directly into the motherboard. It acts like a central hub or a busy city with roads connecting everything together so that information can travel from one part to another very quickly and efficiently. Think of the motherboard as the foundation of a house. You can't build the walls, the roof, or put furniture inside without a solid foundation to hold everything up and connect all the rooms. The motherboard does exactly that for the computer's components. It provides the physical structure and the electrical pathways that allow the brain, the CPU, to communicate with the memory, the RAM, the storage, and everything else. Without the motherboard, the parts would just be a useless pile of electronics. It's the unsung hero that physically holds the team together. While RAM is for short-term memory, the computer needs a place to store things permanently. That's the job of the hard drive. The hard drive is the computer's long-term memory, like a library or a filing cabinet. It's where you save all of your files, photos, music, games, and even the computer's main software, the operating system. When you turn your computer off, everything in RAM disappears, but the things saved on your hard drive will still be there waiting for you the next time you turn it on. It's your digital storage locker. There are two main types of hard drives. One is the hard disk drive, or HDD, which uses a spinning disk to store data, kind of like a tiny record player. The other is a solid-state drive, or SSD, which is newer and uses special memory chips. SSDs are much faster because they have no moving parts, so your computer can start up and open files in a snap. Think of an HDD as looking for a book in a giant library, while an SSD is like having a magical book where the page you want appears instantly. Of course, none of these amazing parts can do their jobs without electricity. That's where the power supply unit, or PSU, comes in. The power supply is like the computer's heart. It takes the powerful electricity from the wall outlet in your home and converts it into the right voltages that the delicate electronic components inside the computer need to work safely. It pumps this power through various cables to the motherboard, hard drive, and every other part that needs energy to function. It's a crucial piece of the puzzle. Imagine trying to run a marathon without eating any food. You wouldn't get very far. The computer's components are the same. They need a steady and reliable source of energy to perform their tasks. The power supply ensures that every part gets just the right amount of power it needs. No more, no less. A good power supply protects the computer from spikes in electricity, keeping everything running smoothly and safely. It's the quiet worker in the corner that provides the lifeblood for the entire system, allowing the magic to happen. So, let's put it all together. When you turn on your computer, the power supply sends electricity to all the components. The motherboard wakes up and checks that everything is connected. Then, the CPU, the brain, starts to think. It pulls the main instructions from the hard drive, the library, and loads them into RAM, the desk. This is when you see your computer's operating system, like Windows or macOS, start to appear on the screen. It's a fantastic sequence of events that happens in just a few seconds. From that point on, it's all about teamwork. When you click to open a program, the CPU gets the command. It finds the program's files on the hard drive, loads the necessary bits into the super-fast RAM for quick access, and then processes the information to display the program on your monitor. Every single action, every mouse click, every key press, every video that plays, is a rapid-fire conversation between the CPU, RAM, hard drive, and motherboard, all powered by the power supply. It's not magic, but a beautiful and fast scientific dance happening right inside that box. Jim Haxa out.